Yeah.
I spoke to Jacob Gable and
oh, really?
And tried to get him on for this Sunday or, whenever he's available. And he said he has his daughter on the weekends, so and then I invited him on this upcoming Tuesday. Haven't heard back from him yet.
Nice.
Cool.
Because he got another mention in the last Thunderbolt podcast that I think came out last night.
Oh.
Yeah, the Saturn hexagon. They were like, as shown by Jacob Gable.
Score. That's awesome.
Hello.
Hello.
Hey.
How's it going?
Not bad. Pleasure to meet y'all.
Yeah. Shall we introduce
Richard? Yeah, this is Richard. He's a new. I think he's a new listener to our show. He's hopped on, and he was very excited to. Since we had a great conversation yesterday, and we didn't have an opportunity to bring in anyone, since we were going to talk at least remotely into Saturn stuff, I kind of promised that we would at least talk about something like that. And Julian's not going to be around. Richard and I had a great rousing conversation about it, so I figured I would bring him on, if nothing else, to meet people. He's from the Toronto area.
Welcome, Richard. Nice to meet you.
Yes, nice to meet you. We were just talking about the hexagon on Saturn, so I guess that can all blend in very well in the conversation.
I think so, too. Welcome to the September 23rd edition of The Electric View. I'm Neil Thompson. Today we have Dave, Jim, Robert, Buddy, Heather, Edwin, Eugene, and a new friend who we'll call Richard II. We are talking about the various celestial histories, the underpinning of planetary mechanics, and where our sun is going through the galaxy. Please like and subscribe below.
Pleasure to meet you all. Thank you very much for having me here.
Sure.
Can we also at some point talk about the autumnal equinox cracks in the magnetosphere that allow beautiful aurora to come in right now? Can we touch on that later on?
We can touch on that now.
Yes.
We just started.
Happy equinox, everybody.
Is that
Happy
what it
equinox.
is? Oh.
Yeah, it's the equinox, yep.
Well, that's good, I guess. I don't know if that... I don't know what that might mean electrically, but I do know it's the days have the equal lengths, I think. So, day and night, right?
That's kind of what I was curious about, electrically speaking. Like, how is this? Because, spaceweather.com will even say the cracks in the magnetosphere that allow more solar wind to come through, or something of that nature, that creates greater aurora in the poles this time of year.
It does? I didn't even know that.
Yeah. Actually, the vernal and autumn equinoxes are the times of the year when you have the most pronounced geomagnetic activity. But it's there's a few factors to this, but one of them, for example, is the orientation of our magnetic field. I mean, the axis of Earth is tilted 23 degrees to the plane of its orbit, right?
Right.
So, so in spring and autumn, we kind of move with our axis directed forwards, sort of. Whereas in the summer, whether it is northern or southern hemisphere, kind of one of the poles is tilted towards the sun. But in autumn and spring, the poles are aligned with our direction of orbital motion, with the tangent to our orbit, essentially. So, and because the solar wind is screwed in this spiral, which is called the Parker spiral, when we move, so it kind of doesn't come directly from the sun, but at an angle. So there's a slight, actually quite big component to its direction of motion, which is kind of forwards in our orbit. Well, quite hard to explain without pictures, but essentially it comes down to the orientation of our axis with respect to our orbital plane. Yeah.
And as I understand it, I believe that you're talking about the solar wind that's being captured by the magnetosphere of the planet, as opposed to the Birkeland current that's coursing through the planet.
Well, yeah, I'm speaking about solar wind because I don't know. Well, there are obviously hypotheses about Birkeland currents coming from somewhere else, but I don't know if there's enough observational data to support these claims.
Yeah.
So you're saying that's what's keeping us where we are? What push and pull, like two pressures pushing at one point that keep us in our space, our location, orbitally speaking? Is that what you're saying?
Well, that's what Donald Scott was trying to model with his idea of our entire solar system being strung on a current filament, and you can explain a lot of weird orbital dynamics that way, and like inclination versus eccentricity relationship, and even planets orbital planets axial tilt can be best explained that way too, like where compared to its planet's eccentricity, basically.
Correct me if I'm wrong, but our position in the solar system is based on the amount of voltage that our planet carries, and I thought that's the way it worked.
And it's kind of backwards. Like in Wall's electric comet model, that like a comet should charge or discharge as it moves in or out, but it's not. It can't be that's driving the orbit. And very simply, because we wouldn't have, if it was due to any electrical effects, when objects charge and discharge, that should change the force. There wouldn't be an inverse square force like we have if the voltage difference mattered in the orbits. That's why even Wall would argue for gravity determining orbits, and he would argue that objects in general are shielded from each other, and that's why there's really no room for electrical attractions between planets. Otherwise, you would have like repulsion somewhere between. If you want to say electric attraction between a planet and the sun, then you would have electric repulsion between planets, or something to that effect. So
maybe it has something to do with the amount of mass that the planet carries, as to the amount of charge that is delivered from the Birkeland current from the sun. The way I'm visualizing this is Birkeland current feeding the universe, splitting off into smaller Birkeland currents, Z-pinching on stars, making stars and gas giants, and on a smaller scale, Birkeland currents pinching off from the one that's being fed to the Earth to our kundalinis and energizing our chakras, and on a smaller scale, even down into the atomic, is where we get a representation of our genetic structure, the double helix, which is a Birkeland current as well, and probably even down into the quantum level. We expect to see, I would think, representations of a Birkeland current that even down at that smaller scale.
You can visualize it, but we don't know for sure. That's certainly something that we want to explore.
Except that
this is a radically different model that we've obviously, with Jim, he's certainly brought it onto the table, and it's pretty fascinating to explore.
Well, there's a lot of evidence that like light and particle beams travel as Birkeland current, as Bessel Gaussian beams. So that's effectively a Birkeland current, and that works all the way down to even the scale of lighter charged particles. So yeah, Birkeland currents go
the quantum
all the
level,
way.
in other words, yeah.
Right.
Now, I'm just throwing something else out there with it. How could diamagnetics figure into that? Does it at all? Could diamagnetic effects be what's helping to keep us arranged the way we are?
Well, you touched on it before, when you talked about astrology, and you mentioned the influences, and this is accepted, the influences of Jupiter on our planet, more than the gravitational, or seemingly, even arguably now, is it even gravitational? The relationship between what is it? It has Shepherd comet or Shepherd asteroids ahead of and behind it. Jupiter does. But besides that apparent gravitational effect, there also seems to be the charge. To be such a big body and such a high charge, I can see that it has. Even though we are shielded technically, we just look like our magnetosphere to Jupiter. We do seem to have some effect. Seems to have some effect on us. We also notice the other anomaly with regards to Mercury. It's which might be better explained through Jim and I guess in this case Don Wall's idea that there's because is Mercury the Mercury anomaly? I think it's spinning too fast. It's for its orbit. I'm not quite sure. It implies some sort of difference.
Mercury only spins one time per orbit. It goes around one time, and as it goes around one time, it spins one full time. It doesn't spin fast.
No, it's actually not the case. I think there's like 1.5 times or something like that.
Okay, but still, that's not very
I'm not exactly sure, but it's definitely not 1 per 1.
Is it Io that of Jupiter's moon that is being held in place physically, that they see the magnetic flux ropes / Birkeland currents connecting Io to Jupiter and basically holding it in place?
I would not. Electricity doesn't necessarily hold. It creates the force of electricity is like basically described by using the I think it's called the left-hand rule, where you put your finger in one direction will point the current, and then your magnetic field goes in the other direction, and the force applied is like where your thumb goes or something. Anyway, that rule tells you it's sort of it works on a right angle. So it doesn't necessarily hold, but it will spin something. It clearly, the Talbot volcano, as you were mentioning, that's the big kicker right there. There's a really good animation of the Talbot volcano, which is on Io. And you can see that it's a large plume. Just looks like the top of one of those magnetic fields.
Yeah. I've seen that image before, and that's not a volcano. That's a.
No, it's not. I just used the conventional name.
A glow. That's a glow mode. Electric discharge.
That starts with T. Talbot. Yeah, on Io.
Thank you.
Yeah, no problem.
Thank you.
But is there? I mean, I'm just kind of feel like playing skeptic today.
Feel free. We need someone to keep us grounded. Otherwise, we're going to go in la la land.
Yeah. Okay. So is there any way? Is there any way to definitely rule out the possibility of normal volcanism on Io? Because
black and white image in the middle of the screen. Sorry, I didn't mean to interrupt you there, Eugene. That black and white image right there in the middle is the animation for it.
This right here?
You can see a little bump on the top of the knob, the black and white image. At the bottom of the... Okay, well, that's below the bottom. But
okay, yeah.
Bottom middle, I guess. Or now middle.
Here?
A little bit up. A little bit up.
This one?
Next to the red one.
That one right there, yeah.
NASA.gov.
Yeah, that's... You can see the animation as it sort of goes through, see, like that. Anyway, go on, Eugene. I'd like to hear the counterpoint.
Well, basically, I wanted to say that it might be like regular volcanism plus electricity on top of it. That's what I'm basically thinking about. We know that there's a huge, strong currents flowing from Io to Jupiter, obviously.
You can see the footprints on the aurora of Jupiter, I think.
Yeah. not only that, but Jupiter also has these strong radio emissions, which basically are generated by the current between Jupiter and Io. That's why Jupiter has these Whistler radio waves that can be easily picked up by amateur radio astronomers on Earth. And so it's that strong. Like, it's really amazing.
Oh my God. I know that voice. I've heard it on a presentation on Thunderbolts. I just sorry to interrupt. I just went, oh, I know that.
Okay.
Yeah, well, you're famous there, Eugene. You're famous.
Yeah, it feels pretty nice. So,
oh yeah, he's totally fanboying us. He was like, dude, I can't believe you guys, you work with the Thunderbolts? I was like, yeah. It's like, oh my God. And they're all from the Thunderbolts. It was very nice to hear. I was all like, oh, thank you. Just like that, with a big smile on my face. I was all proud after I talked last night. We met. So anyway, go on, Eugene. Sorry.
Yeah. So what I was telling basically is, could these be actually the volcanic eruptions that are later ionized and so on and so forth, and so there's this glow and plasma behavior, which is obvious, I think, but the underlying reason behind this, maybe it's really a volcanism. This is a question. I'm not stating it.
No. I like what you had to say. One of the things that I found to be compelling was if you see the images from NASA that paint. The animation alone is pretty damning because, of course, you don't see volcanoes do this really cool effect that goes in a big, a rain down sort of effect that seems to be going on with the animation of the volcano. But direct pictures of the volcanic area over time shows how its cliff face is being eroded and it's drowning out the sensors. It's so bright white. It's like it's arc white, and in their images they will paint it sort of yellow, making it look like lava, as if a lava flow would occur on the edge of a cliff like that. But that seems compelling. That it's so bright it's drowning out the sensors, and that's arc light basically is what it seems to be. And given,
or are we? Sorry, are we just witnessing the creation of a brand new creator on Io?
I think it's more. I think it's eating the whole cliff face away. It looks like it has eaten since every year. It looks like it drops back a kilometer or two, like it's just being chewed out slowly to the new level. I don't have any pictures myself, but that little fact alone seems compelling compared to the idea that it is actually a volcano. We don't see lava flows, for example, or anything like that. So.
Could it be
so far?
Could it be in fact the same process that stripped off 6.5 kilometers of the northern hemisphere of Mars?
I'd say that's probably a good bet, and probably from similar. I mean, with regards to we know that they do that if given time, things will can be eaten away to a very smooth level. With electric machining, we know that from experiments.
Possibly that's a little amount of energy. What if the energy level was ramped up order of magnitude of 1,000 or 10,000? That might take place in 1 day or 2 days and just devastate a world in a very short amount of time.
This is actually what we were having a conversation with the idea with Andy Hall. Whether or not things that we consider volcanoes on Earth were actually electric as well. That is interesting because now with mechanisms we're not quite sure, especially if we didn't see the eruption. And some of the eruptions we do see are monumentally disastrous, like to the nth degree. That's a good little shot there. But like for example, it's like, oh, it's just Mount St. Helens, and then the explosion was not. I mean, it's not something you would just be shaking a bottle of Pop Rocks and Coke or something, or Mentos and Coke or Diet Coke, and watch the thing explode. It's not that kind of pressure. It's not a pressure. It's it was a nuclear explosion. It was so loud and popping, But
it resembles more a geyser than a volcano, and I want to know why we've categorized it specifically as a volcano. I mean, how do we know that it's not some sort of geyser?
NASA tricks.
There's also another question.
Sorry.
Actually, on Earth, for example, the primary component of eruptions, volcanic eruptions, is water vapor. So I'm curious, what is the elementary composition of these supposed volcanoes on Io? I mean, if it's just like surface erosion, then there would be only the elements that are found on the surface, right? For example, we don't see we don't see much water on the surface. So maybe if we can definitely say that it's a silicon plus aluminum plus whatever, then it would rule out the possibility of volcanism, maybe.
Oh, it's quite possible. Well, but we've seen how hard they really hold on to that. I mean, when we were talking about Enceladus, I think the one of the moon of Saturn, I think it is, and they had to explain the giant plumes coming off of that, which are suspiciously like the Jacob Gabel's work, we'll say. Those plumes are considered their theory is cryovolcanoes because it's so cold it can't possibly be actual volcanism. And then basically that's sort of like ice geysers, as if that could even be a thing. I mean, that literally is unscientific because there's no evidence for that at all. That's almost ad hoc, like just throwing something and see if it sticks type science. I'm not kind of, yeah.
Yeah,
I'd like to put this out for consideration. We went to the moon in the 60s. We had the technology to even go further at some point down the road in the 70s and 80s. That was all stopped. The reason being is because if we put man out there with instruments, questions would be asked.
Well, and we do send instruments out there anyway.
We would be further ahead in our knowledge of the electric universe if those questions had been asked. I think that's probably the reason why that was kiboshed.
Consciously or unconsciously protecting the conventional theory is I can't judge people for doing that only because they thought that they were doing right. It is the people who are forgetting to state their assumptions that are causing problems. They don't even think they're making assumptions. That's pretty damning right there. When people think that they're actually no, we're not making any assumption. We've never made an assumption. Well, you have, and you're not stating them. And by not stating them, you have tricked yourself into thinking that this is all there is. And this is why we're having this debate now, basically, because they're not having one. And they certainly should be. Whether it be, why are the clouds on Jupiter banding like they do? Why does that sort of process happen on Earth? None of meteorology says that should happen. The volcano that looks like it has a plume and coming down, but they stick with their buildup of heat and then pressure, and they think this heat is caused by gravity and so forth. That's the only way the gravity bending the moon somehow and causing tidal forces to cause these volcanoes is their mechanism, and that it seems reaching. Considering the forces that we have, or that we can experiment with in the laboratory that seem to belie an electrical nature. I think, anyway.
Yeah, it's all instabilities in electrical fields within the planet generated by the Birkeland current that's coursing through everything at every scale.
Well, and this is what we were right back to what Jim was saying. Is it coming from? Is it coming from the sun only, or is the spacing of the planets predictive via the nature of the current that's running through the solar system? That's a nice one. I like that.
What else do we have about recirculating currents or alternating current? So if because when things go in retrograde, we have that feeling of a toy car being
tug back. We've talked about that metaphor before about like wind the wheel and then let it go, and then it, you know, projects itself out forward much further than it was pulled back. And that idea of things pulling in different, like kind of rewinding themselves a little bit to allow themselves to go forward again. As
I understand it, I believe the Birkeland current is alternating current. It can flow back and forth either way.
But we also talk about the difference between man-made alternating current and natural alternating current. And natural alternating current is continuously moving through. There's no stop point. You know, the currents kind of rotate into it.
Right, and they're represented by the counter-rotating drums of electrons. That's the alternating current.
As opposed to... Go ahead. No, go ahead.
Oh, I was saying, from my initial... I mean, I like some of these ideas that I'm seeing here, retrograde motion and so forth, but obviously, if we're moving towards or from another body that's in our next orbit, it is possible that our not just gravity, but the electric field that we have could be causing some of the electrons to move to one side of a planetary body or another more than the other planet, like basically give the planet a polarity. I can envision this, but as we said, we're not quite sure if that's exactly true, but you've pointed out some interesting points when that does seem to be true with regards to things in astrology. So I've learned to keep an open mind on that now, because I'm not...
Big smile.
Well, when I learned from someone else that they don't talk about the fact that Jupiter does influence other planets, not just gravitationally, but somehow, because I mean, you put Jupiter over here, and then you're between that and the Sun. You're in a different place, electrically speaking, than you would be if this Jupiter and the Sun were on one side and away from you. You know, that could have a bearing, just charge-wise speaking, just because the charge of Jupiter is so large. I mean, like we said before, if we could see it, it would be bigger than the Moon. It would be huge. Just the magnetosphere, I mean, alone. So, and we do know that it has enough power to start sculpting we barely have transient lunar phenomenon on our Moon, but the electrical or magnetic force of Jupiter is like etching Io all to pieces right now.
Right. Well, aren't we in Jupiter's magnetosphere all year round, and in Saturn's magnetosphere 6 months out of the year? Am I?
I can't attest to that. Actually, I don't know.
No, this is definitely not correct. No.
I'll go with Eugene on this.
Okay, yeah, but please clarify that a little bit, because I have read that before. Not just, I mean, obviously, astrologically speaking, we think we're always connected to everything, but I've read science papers that refer to that, and I've heard other people say it before. So how is that? I mean, is it just like the size of the magnetospheres that we're reading, or is that like you can see a definite end to where their charge is that is no longer touching other charges?
Is it possible that when we're the closest to Jupiter in relation to our orbit, that possibly the size of Jupiter's magnetic field might come in contact with our magnetic field at some point when it's the closest point to us?
Let's let Eugene answer. Let Eugene answer Heather's question.
No. We definitely cannot touch Jupiter's magnetosphere. And responding to Heather's question, how can we determine that? Well, basically by the parameters of solar wind. So we can see where the solar wind starts behaving like it's interacting with something, namely the magnetosphere of Jupiter. Right. And it's this area is way smaller than the distance between Earth and Jupiter. It's definitely very big. Like, I don't know actually how big. Well, certainly not bigger than 1 astronomical unit, I would say. Actually much smaller, I would think. But between us and Jupiter is at least 4 astronomical units. So, in case of, well, it's at the closest approach. I mean.
Or
is it
No, it is.
Yeah,
It's 5 AU away, and we're 1. That's what the closest we could
it.
use for.
Yeah. So it's 4 astronomical units, and the size of its magnetosphere is smaller than 1. That's what I can say for sure.
What's the definition of what that is? The threshold of inside or outside?
Well, it's as I've said, the parameters of solar wind should be changed somehow. Well, basically the protons, electrons, and so on from the solar wind should start interacting with these magnetic field lines.
Mm-hmm. We do see this type of signature, though, right? This Parker spiral, right?
What do you mean? Where should we see it?
Well, as far as our measurements of the magnitudes, right? This is a map of magnitudes, correct? Going out radially from the sun.
The ballerina skirt of the solar wind, it looks like, yeah. That's what they call it.
Is that correct? Is that correct?
Yeah, and it would be perturbed by the presence of Jupiter or any other body with.
So how do we measure that? I mean, I can hear the statement, but it's like that means
okay,
how it's measured and like how dense is the data.
Okay, so we can measure the speed of the solar wind, we can measure its density, we can measure its magnetic field strength, and so for example, in the forward side of Jupiter, I guess the side that is closer to the sun, on that side the solar wind would fall in onto its magnetosphere, and as it sort of resists the solar wind in penetrating into it, the solar wind would slow down, it would become more dense, so there would be also a bigger density of the strength, magnetic field strength of the solar wind itself, and as I've said, those effects are only observed. Well, I'm not sure what the size of it is, but it's right. Definitely smaller than one. I'm going to do a little. This is me being an inquiring person, so please understand the nature of like how I direct this, because
when you say inquiring, do you mean shit disturber?
As usual.
As usual.
But the term is it's amorphous. It's used. I'd like to hear at least what's accepted in the mainstream scientific community as
satellite
what solar wind is. What's the measurement? What is the method of measurement, and what type of sensors do they use to measure?
Just a short interjection there. I would argue that's the reason why we send out probes and satellites, right, to do that kinds of measurements.
Every time,
but are we measuring potential? Are we measuring, some type of Helmholtz?
No, I'm not. I couldn't tell you what kind of instrumentation they were carrying on what specific satellite, but usually they carry a whole bunch, meaning they.
Of course. Right.
Yes, so we send them along the planets. We've done that a couple of decades ago, so we did accumulate a lot of knowledge there, right?
Right. But there's certainly just the term itself, and it's very often with these simple things.
Well, very recently,
I'd like to hear how it's what's the data, just the facts, ma'am.
Well, what was the name of the last mission to Jupiter? Juno? Was it Juno?
Yeah.
Yeah.
And
that one was sent there, and it's still there, and it was sent there for the particular reason. When I looked it up a couple of years ago, a year or 2 years, what is it ago now? When I looked it up, it was there for all kinds of specific reasons, meaning they were redoing their homework. So what is Jupiter made of? How strong is its magnetic field? How strong is its gravity? Does it have a solid core or not? Etc., etc., etc. So that's all part of the mission. So I guess we should look it up, what the results are. I'm not sure how forthcoming they are with the data, but that was the mission, more or less.
But it's still coming in.
Sure, but by now they should be able to say something, right?
Right, but like even still, Cassini went down last year, and they're still releasing new information from the data they're analyzing from it.
Sure.
But I think what Neil was trying to get at is trying to give the solar wind a proper descriptive as more an electrical phenomena, as a more positive region of space as opposed to a more negative region of space, right?
Yeah. There's definitely a voltage gradient. There is.
Is it potential? Are they measuring potential?
Well, we have measured the actual voltage potential. I don't know exactly how, and I would like to actually, now that I think about it, I mean, I do know that we have certain satellites around the sun, and that we can see things like certain flux pass the satellite, and then we see it connect to one closer to the Earth. Then we can even without that, we can still gauge the speed as they're coming off, and we know that certain places where there's sunspot, it seems to move faster, and certain other places it moves slower. It's certainly not uniform in any sense. This implies that there is and we know that it accelerates. So we know that it's just like any ion put in a magnetic or electric field. If you put one in an electric field, it will accelerate. So that is likely the mechanism which is throwing it towards the heliopause. But it's not kinetic, it's an electric thing, but it obviously gives out a velocity of items. Now, Eugene and I have had debates before, like in the conventional cosmology idea, that there is an actual wind pressure, and I have said, well, this is more of an electrical pressure. This is where the magnetic moment occurs, separating the Earth from the solar plasma, the sun's plasma, so to speak, and we're immersed in that, and that sort of encapsulates, and the charge associated by the charges going by tell us how big that will be. It is commonly, just as Eugene described it, very common in conventional astrophysics that there is actually wind pressure, and this is a pressure. But we're beginning to learn now, and I think they are too, that we can see reaction. We can see plasmoids in the Earth's magnetotail. We can see that there is a discharge along the tail as it's trying to, because it's a different plasma, and the barrier between these two plasmas is has the ability to carry current. So you can sort of ground out the place where the arrow is here, for example. That part is electrically connected to wherever that tail ends up, way, 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 way out there, off the screen to the right. And so these are, this is where this, and of course, this is probably what's powering. And the idea is that current alone going in the North and South Pole, giving the magnetic field, giving all the weather of Earth, giving it, is that really happening? Or is, of course, there more to it, and the actual current that's powering the sun is actually going through the Earth as well? That's an interesting idea. So. We're not sure yet, but the idea of mechanism, most of the time now, we're pretty good. I mean, they're called, I think, the SOHO satellites. I'm not sure if I'm using that correctly. I think there's like 6 of them, and they basically are the boys and girls that we get the data from of the solar wind.
Are the magnetic? I got a question. Are the magnetic flux lines of our magnetosphere? Can you equate them to double layers and separating the solar wind particles and moving them into particular trajectories around and into the Earth itself?
Well, technically, the magnetosphere to the solar wind, that alone would have to be, by definition, a plasma double layer. It's not a very strong one. Well, at least it doesn't appear to be, at least.
But would that separate the charge of the solar wind and not allow the solar wind to interact?
Oh, it can't go through it.
Only at the poles.
That would be likely. That would be a correct electrical interpretation. But we still have to actually check, that we're inferring our knowledge of plasma and the rules of electromagnetism, and we're projecting it onto a model that has been, up until even 30 years ago, is thought mostly to be a physical reaction. There is a physical wind, and that physical wind is pushing on the magnetic field and causing it to ripple. And until we actually sent satellites up there in the 50s, I mean, this is why Kristian Birkeland is called Kristian Birkeland, because him and Sidney Chapman had a large debate on the actual nature of the magnetic field of Earth. He thought that it was open field lines and was connected to the sun, and Sidney Chapman said it was all enclosed. And until the 1950s, and even taught to me in the 70s, is that it is all enclosed. And but obviously we learned in the 60s and stuff when we sent up satellites that it was not. They were open field lines. And Birkeland was correct. And therefore he didn't have to commit suicide. Chapman is a dink, and we have the word Birkeland current. Sorry,
Is that why he committed suicide?
Well, he did. I don't know why.
Yeah, Tokyo.
Well, those Japanese.
Wow, I did not know that he committed suicide. Wow.
Yeah.
Well, if he was doing experiments on, like, actual experiments, building the stuff in the lab, doing what we consider science, and then people who were, in a nutshell, you couldn't prove them wrong because there's no instruments up in space. So since there was no instruments, Sidney Chapman's mathematical model seemed to work better. Therefore, you can go shove it up your, whatever there, Kristian Birkeland.
So he Harry carried himself?
And then they basically ruined his
They
career.
ruined his life. And this is where the idea of this is where Hannes Alfvén and stuff, his intellectual descendants, continued from there. And but he is the first one. He was actually doing actual real experiments, and this whole let's just do it with math. The math will work better this way type attitude, which of course the Big Bang is probably, if I think too hard on it, probably a direct type of feeling to that, really. But you can't prove it because you will never get to actually go back in time and see, so you can't prove it, or you can't actually put a probe in another, like up near a black hole, so you can't prove it. So we can say whatever we want, and that type of attitude is unfortunately sort of prevalent.
Make a name that immediately puts an image in your head of what it is.
The solar wind, for example, yeah.
For example, yeah.
And I think Eugene has ran into
where
the
my
exact...
reactivity comes from.
Oh, and with merit, sir. It pisses me off too.
Excuse me.
Yeah. but Eugene has pointed. I think you've pointed out similar situations when you start entering into the quantum. Eugene, where things get descriptive and they lose cohesion. We have effects but no mechanisms, type of thing.
Well, the problem is more with like humanitarian understanding, I guess. I mean, you have formulas that kind of work, but you don't understand what you're doing and what you're getting, essentially.
I think that in cosmology, they are predicated on the assumption that they have to seem like they know because this is such an important thing.
But I mean, that's an interesting topic. I think is it crucial for scientists to present themselves where they know? I know just as someone who's like an engineer, but I build things, right?
Right.
99% of I won't go 99. 95% of the time, I don't know what's happening. It's like it's broken, and I don't know how to fix it. And it's like this is my life as an engineer. It's like I design things and build things, and they work eventually, but most of my life is spent confused, and it's the presentation of academic science. Is it a necessity for them to present themselves as all knowing and all seeing when we really know that they're not at all? So.
Well,
and is it really smart of them, people that have probably an average IQ of 160, to burn them in
IQ, what about
these
that
books?
one? I don't even like that. IQ is a private problem with that one. So.
Well, but he's not wrong. Is it wrong that when if it was truly more scientific, there would be a lot of people who coming from different points of view and arguing their points of view, but coming up with peer review and then consensus, and then ostracizing those that don't fit with the consensus is not doing anyone any favors, especially considering
it's
what
a calcification. It's a silo calcification thing.
It's putting, it's putting institution before search for truth.
Yeah, I think so.
Turning it into a religion.
Well, and
Right.
that's Sheldrake right
for
there.
sure. Yeah.
Like we talked about.
Yeah.
Yeah. He would totally go, "Yep, this is scientism." But
Do you ever notice that in a lot of articles that are in the magazines now or publications that they say scientists believe?
Yeah.
That right there is like a faith basis.
I was like, I think, I mean, the classic one was the one with 97%, scientists agree, but the other 3% are, it's
It sounds like an advertisement for toothpaste, doesn't it?
It does,
Mm.
right.
97% of dentists recommend.
Right. 4 out of 5 doctors recommend Salem cigarettes, so. Yeah, which was actually a commercial. So.
Right, I remember that.
Oh, that's crazy. But, they don't tell you that they loaded the deck either.
Yeah, but it's just, So.
But it's just like anything else. It's like, you take a poll, and what are you? What's your pool? Where are you taking this from? CNN makes all kinds of polls, but they ask CNN viewers. Just like Fox News takes a bunch of polls, but they ask Fox News viewers. So obviously they're asking questions that focus audiences. You know what I mean? This is the same thing that's happening here. It's like, let's ask these people who we know will answer the question. I read this awesome quote the other day by Albert Einstein, and it was like, the formula for success is A plus B plus C equals success. And it was A is work, B is happiness, and C is keep your mouth shut.
Yeah.
And this is where I think it was actually Hannes Alvane or someone of the sort who said if they would just have walked across the hall and asked the people down the hall or whatever in the room next door, they'd have the answer to their question. And we were talking the destruction of natural philosophy itself, breaking things down into specialized groups where, we know all the laws of electromagnetism. We're only allowed to apply them to what they tell us we're allowed to apply them to. You weren't allowed to apply these laws to astrophysics. They have their own set of laws there that is contrary to the reality of the situation as we know it as engineers, but they apply it there. And that type of stuff, because I'm allowed to work on a computer, but I'm not allowed to build a Torella, well, even though we do, but you know what I mean, like to actually infer and to experiment and to then apply those experiments to what astrophysical objects is not something you're just not allowed. It's literally not, because the moment you do that, you're challenging their faith in Einstein, and believe it or not, he is a god to many of them. I mean, you can watch, what was that called, that show, The Big Bang Theory, and watch how silly they are if you think about, because people are human beings. We have the human being flaw of wanting to be right. We have ego. We want to be on the right team. There's tribalism. All of that plays into it, and it knocks, in a way, the pursuit of truth off course.
Yeah. I mean, there's an amazing thing with another quote from Einstein that I really like, and it's about fish. It's like you're never going to get a fish to climb a tree, and he was making the analogy to academics, where it's like this climbing up of the mathematical quote unquote Rube Goldberg machine. But a fish can swim quite well, and it's not allowed to swim. But I've seen it out here around people who were rubbing elbows with that kind of high ether level of scientists. But there's a whole different discussion of Einstein and it's very interesting how there's all these different layers of like perception, communication within different different groups, in groups, out groups, and stuff.
Well, and it's to be fair to Einstein, it's not his fault either. He
was put up on a pedestal.
He was smart enough to shut up, and he stated that. Keep
right.
quiet, shut your mouth. everybody around him that was actually showing what could be done and what should be done and where things could go was dying. Their families were dying. People were getting knocked off. People were having their life's work ruined. The smartest thing he ever did was shut the hell up. For himself and for his family. I mean, I see.
I wasn't saying that. Go ahead.
No, I wasn't trying to contradict you or anything. What I'm saying is that there comes to a point where I don't want to say like don't fight the man, but it was like at that point he knew that we had to get past some things before we were going to get past some things. So,
yeah, can I draw your attention to Dr. Royal Raymond Rife, the man who cured cancer and was held as the man who cured cancer by the AMA back in the 30s, and then a few months later his lab was burnt and he was suicided.
Yeah. Or committed suicide, but yeah, either way it was suspicious, I think.
But when do they become the Donner Party? When do they I mean, everybody that walked away never came back because they were only like a couple, just not too far away from civilization. They could have come down off that mountain and lived, but they were too scared to move, so they stayed up there and they ate each other. Right? When does science? Like everybody's just kind of like, this isn't working. Let's really examine what's going on. This whole dogmatic regime idea of censorship through group. Okay, we all looked at this and we decided it was okay. Group census says it's all right, so this is what we're going to give the general public. This is what we're going to give as an understanding. But enough people said, that there's got to be something else out here. I can't sit here and live in this. It's not working. There's got to be something else out there. And they got up and walked away, and they never came back. Not because they died, but because they found something else. They found life. And the people who stayed there in it wound up disintegrating and eating each other. When is that point where enough people walk away from these ideas and it dissolves itself?
Well, if they stopped actually funding it, that would probably do it. But one of the things that I think about is that general universal truth that science advances one death at a time, or one could be that one could say in The Structure of Scientific Revolution by Thomas Kuhn, I think, he said that all revolutions just eventually happen because the other people who believe the other way die off. That's just it. That's K-H-U-N?
K-H-U-N.
There it is, right there. Or K-U-H-N.
Oh.
Sorry. Anyway, great book, and it details how what we were talking about here, the tribalism of people, which you can't.
It's very tribal. Ultimately, it's tribal.
We're at right now, for example, if you look at the Kuhn cycle, we're moving from normal science. Okay, we're moving into model drift. We're past that probably now. Because you saw the things with
definitely here.
What was it called? When Stephen Hawking died, his last thing was, "I think that dark matter is wrong," type of thing. That was the last thing he said. So you're already into the model drift problem, and then we're into model crisis because it's failing to make predictions. Now the revolution comes when there's another model available, and this is where we sit, I think.
Well, and then it has to be demonstrable. This is the key.
Well, and practical too. It has to be predictive. If you can, some of the, I welcome, and some of it has already been sort of proven, but you're not allowed to look at it. We've talked about some before, like the fingers of God problem, or basically the way the quasars are stretched out pointing towards the Earth. That can't happen, but according to redshift data, that is the case. One is either wrong, or the other one's wrong, or the Earth is the center of the universe. That's probably not true. Other issues are like the comet theory. We went to land on this icy ball, and we took our ice drill, and we found it hard as rock. Well, it looks like rock too, but it's not. It is ice. So your eyes tell you one thing. The friggin' rover itself is telling you the same goddamn thing. And your answer is, I trust my math completely. because the mass gives you the mass and density of that object. And of course, Wall is saying the mass is different because the body is highly charged, and it's there's a because the two laws are very similar.
They just got
gravitational
it
law
upside
and
down.
Coulomb.
What the function of it is. Yeah.
Well, yeah, and we don't know the relationship. There appears to be one though. And over and above, basically, if we didn't ever go there, I mean, they think that there's literally snow and ice coming off of a comet. That's what they think. They don't think of it the way that Jacob Gable is demonstrating with those wonderful plumes coming off, for example, and that's what the Space News was about, or the podcast at least. And we're getting to the point because the sensors and the data are coming back in ultra crisp high res now, and but it's to the point, do we believe you or our lying eyes? We're and this is where the whole thing is falling apart. And the good scientists keep on going, I don't know what that is. Send another probe. But it's the theorists behind it that are saying, whoa, I can't even keep up. There's so many. How many different little ad hoc things? Cryovolcanoes? Who came up with this fucking shit? And they're trying to piece this together all cobblestone-like, trying to make it all sort of fit, even though nothing really fits. And they're losing their cohesion. They're losing their predictive accuracy, and it's starting to fall apart. And that's what I'm seeing anyway.
We're in a great position.
I actually have...
Go ahead.
Sorry.
No, go ahead, Rob.
I actually had something go from the Denver show that I was at, because we went into the meteorite section, and they all sat there and explained how impacts cause the craters and everything. And I sat there and said, well, there is a new theory now, and I actually kind of showed them some of Jake Gable's work, and they were all completely amazed. Like, that was so amazing. How does that actually happen? I'm like, yeah, it just happened in his kitchen. He hooked up a vacuum chamber in his kitchen and was making craters in the sand. That show.
High five.
Yeah.
Right?
It's compelling.
Like, no, because they were trying to say that can't happen. That would just be too much power to create. That it had to be an impact. I'm like, well, why don't we have a radial arm or a rift somewhere outside of all these craters? They're just vertical walls and, a little bit of shallow ejecta from a few miles outside. There's no trajectory, no, crescent-shaped craters that are elongated from an actual trajectory coming in. They're just straight down. And then I said, well, this would explain why. And they were all completely amazed. I loved it. But, they were all skeptical at first.
There is a square crater on this planet. It's called Barringer Crater. It has it's square. I mean, you put a piece of paper up against it, you find it square with rounded edges.
And even Dome and that Areola, whatever one in Mauritania, they're hexagonal in shape. And I think Ito and I spoke about up here. Yeah.
Sorry, I'm looking at it right now.
That's an electrical discharge. Yes. Poof, right there.
Right.
And the landscape. Well, I've been there. It's Eugene and I actually.
Yeah, we've been there.
Yeah, we've been there.
We were there
and everywhere.
The center has two round spots, if you will. Two impact. Double impact.
Look at that other little one further. There you go.
I saw that out there too. And the landscape is weird because you're going over dunes that are a welded tuft almost. Like you can see that it was sort of windswept or ripped bare, and then a little zorch, just sort of thing. And I know that sounds strange to look at that and go a little zorch, but compared to the rest of the area, if you zoom out, so to speak, you can realize it's just nasty. Like the whole place has been mangled. The Grand Canyon is near the area. You can picture them all happening all in one go, so to speak. That could have been the case. But
so should we return to Jupiter, maybe? I mean,
oh yeah, sorry.
Somebody asked the question: what did we actually measure there? Yeah. And I wanted to answer, but the discussion kind of drifted away.
Well, let's bring it back. That's cool. Juno, we do that.
Yeah, Juno is still there, so if they give us the controls, we'll tell them what to do, right?
Right. Yeah. But, well, basically what they're measuring usually is they have a magnetometer at least, right? So it's measuring the magnetic field of the ambient solar wind or the plasma in the magnetosphere of whatever the spacecraft is orbiting currently, right? And they also have various instruments to detect the particles themselves. For example, I know definitely that Discover and ACE, the spacecraft that are measuring the solar wind that's coming to Earth, they have the so-called Faraday cups to actually catch the protons of the solar wind, essentially. That's what they're doing. But I think those outer planet missions, they've had some other instruments, but they're probably somewhat similar to those. And so essentially we're measuring, and then sometimes they have also other detectors for more like energetic particles, because, well, for example, in the solar wind, the particles are of pretty low energy, but sometimes, you know, when there's a solar flare or something like that, there can be really fast particles. So they have detectors for those too. And with regards to Jupiter, there have been multiple flybys. Essentially, all the stuff that's going to the outer solar system, it usually tends to go to Jupiter first to get a gravitational assist, to get basically a free ride, so to speak. On it. Yeah, exactly. So there have been multiple flybys of Jupiter. So how much? 9 probes have been there, I think, starting from Pioneer 10 in 1973, and currently Juno is there, and all of these spacecraft, well, at least most of them, had these instruments. Well, Voyager's definitely had Voyager 1 and Voyager 2. Then Galileo, that was actually orbiting Jupiter, also had these instruments, and then Ulysses, the spacecraft that was actually sent to probe the polar areas of the sun, but they've sent it to Jupiter first because, well, basically they wanted to change the inclination of its orbit, and only the Jupiter's gravity would allow to do it, like cheaply, so to speak.
I see. Yeah.
So it went all the way up to Jupiter. Then, thanks to the gravity assist, it changed the inclination of its orbit, and it started orbiting the sun with an inclination of about 70 degrees or something like that. So it came pretty close to the polar regions of the sun. So this is basically the only spacecraft that have been orbiting with such high inclination around the sun. And this is where our primary data on the polar coronal holes come from.
And we're also getting a little bit more information, and correct me if I'm wrong, I recall seeing basically, I call them, for lack of a better term, spherules, they look like currents going in the poles of the planet, of the sun, which are...
I mean, we've been looking at this one quite a bit, but this is SDO, I think. But
yeah, those are different spacecraft. I'm not even sure if Ulysses had a camera. I think it didn't. So
right. I mean, this is a fundamental. When this came into our purview or view, etc. How do we explain this? And this is really fascinating and highly compelling. What's the action going on here?
And actually, I've looked up the size of the magnetosphere of Jupiter, and it turns out to be at best 100 radii of the Jupiter itself. So if we take 100,000 kilometers as a radius of Jupiter, so it would be like 10 million kilometers at best, the magnetosphere. So it's still like 1/15 of an astronomical unit. So it's way smaller than the distance between us.
Yeah, but it's but you're determining a threshold of a measurement where any of these things have some type of asymptotic relationship that's somewhat arbitrary where that threshold is. Right?
Yeah, well, I mean, if you're saying like there is at least some influence of Jupiter, like electromagnetically speaking, even right now, like wherever we are, then yes, definitely you are correct. But I mean, well, everything in the universe affects us in some way, you know.
Right. I mean, this is the focus on magnitude only, you know, versus anyway. But, I mean, you kind of see my, I'm often come in from left field, so you know. We really appreciate you being on, but I hope it doesn't bother you if I play Imp of the Perverse occasionally.
No, not at all. I'm frequently kind of asking the same sorts of questions, and I actually only enjoy sharing whatever little knowledge I have on these issues. So,
pardon me, Mr.
You're great.
Left-field.
Yes.
I recognize your voice now too.
Oh,
and it's awesome to hear two contributors talking back and forth. This is amazing.
Right.
I'm sorry to interrupt, but I am just flabbergasted.
Oh, we're really happy to have you, and we love having Eugene on. It's this is a real big treat for me personally. So
well, call me next time. I'll be there.
Yeah, we will definitely, absolutely. You know who really struck me was you brought up was it Paul Lavalette, that paper that you shared. He was the one who was like, it's back in the early like 2000s. I picked up it was Beyond the Big Bang and just started going, and that was my red pill into the electric universe. So it was neat to see you reference him last time. So
can I just mention how I found the electric universe?
Sure.
Well, it all started about 5-6 years ago. I was an atheist looking for something, trying to figure stuff out. Always interested in geology, history, and science, and ETs and all of that stuff. And I'm searching around, reading stuff from Sumeria and Egypt and Indus Valley and South America and North American Indian stuff, and putting two and two together. And then all of a sudden, one day, I come across symbols of an alien sky. And I went, oh my God. I just made the biggest connection I have ever found. Then I found Remembering an Alien Sky and Thunderbolts of the Gods.
Remembering the End of the World.
Then I started that was 2 years ago. Then I started absolutely beating the hell out of the Thunderbolts project page. I've watched video upon video, talking about the structure of atoms, how they think it is and how we think it is. And
actually, that's Edwin right there.
Hi there.
Yeah, he's the guy that came up with that theory.
Wow. I am just, again, flabbergasted. Thanks again, people. I'm like, oh. So
Deal.
Just for you there, Dave. Got your fan.
No,
and I'd like to add, that's how I came to the knowledge of putting the concept of God together with the knowledge I gleaned from the electric universe and the knowledge that I gleaned from Nikola Tesla on his research into scalar waves, and everybody else that has come since into scalar waves, telling us that these scalar waves are trillions of times faster than the speed of light. And that's instant communication. That's the God thought everywhere, all the time, all knowledge everywhere, from here, there, then, now, past, all of it. And the Birkeland currents, Z-pinching, pulling matter in, creating matter, that's God doing his work to create our universe. So that's how I came to the nature of God.
It's kind of funny. I've always grew up in a situation where I had discussed biblical stories openly, and my mother was religious. My father not so much. But I found that I still, even when I sort of lost the desire to follow down that path anymore, I didn't want to become a priest or something. Then I still had reverence for the stories. I mean, you don't ingrain something so important into people without a purpose. There's the you must remember type feeling. It's like to me, it was like a voice screaming from the past saying, "Hey, something happened, guys, a whole lot of shit happened. What happened? I don't remember any of these stories, but it was bad." And that's kind of how I feel them screaming. Like, but if you go back through the text and back, you can start piecing together. And I think that you were right. One of the things that's very compelling about the David Talbot's words was his work on the archetypes. That, and of course, this is where David and I would have. David and I disagree. I think on the you have a more Carl Jung approach, and I was more in the Talbot area where the and this is still but this is the crux of the matter. Yeah,
well, it's in process.
Yeah, well,
kids
are both wrong, but we're going to learn by talking. So
yeah, absolutely.
Yeah, it's for me. It was a question of all texts everywhere contain some basic truths to them and some basic talking points that are everywhere. Not just including archetypes, but storylines and the fact that two brothers, which I believe is Saturn and Jupiter, may be represented by Romulus and Remus, and the Aztec two brother gods that went under the water, and so on and so forth. And in Egypt, as well as the story between Horus and his uncle. That's another aspect of the two brothers. But one's an older brother, one's a younger brother, and the brother of a brother. You know what I mean? They all have certain aspects, and it's all based on something that happened in the sky, I'm thinking. And I also believe firmly that there are the big gods, the planets, and then the small gods, which are some ET races that came in and messed with our DNA, creating us from an ape-like creature that was on the planet, as we have 46 chromosomes, and they have 48.
Someone was talking about this, weren't they? Weren't we having a conversation? Who was that? Who was talking about
we
this?
were. Yeah, I brought that up, the number of chromosomes, etc. Well, it's a very interesting thought, but we
don't usually dwell in it because we do need
to find some evidence there, or at least some constructive avenue if you want to explore that road, if you will.
I've also heard the idea that giants might also be instead of aliens. I also saw that, or the cone heads might have been them too, but that could be an offshoot of humans. I don't really know. I don't know anything.
Do you know the work of Lloyd Pipe, Mr. Dutchman? I'm also a Dutchman, by the way. But
right, nice to meet you there. So the cone heads in my book would be a feasible and realistic avenue, if you will, to explore that hypothesis. Right? It's either right or wrong, and if you can find these anomalous skulls,
they're in Peru, the elongated skulls of Peru. That's the cone heads you're speaking of.
Yes, and Brian Forster is doing at this moment. There are tests being performed on several skulls. He collected some money.
The tests have already came in that their haplogroups are connected to peoples found in Basque Spain, peoples found in Northern Europe, and peoples found in Turkey.
Yeah, and that puts our historical context of that area a little bit in dire straits, right? But still, I don't know. Are there real results in yet from those laboratory the results?
Yeah, go to Brian Forrester's YouTube page and look back about 2 months ago, 3 months ago, and he said some of the genetic tests have come back, and that's where they found the haplogroups that have come from Northern Europe and Spain and Basque.
Yes, but they're doing some extensive testing now, I believe. That's going to be mighty interesting.
Right? Yeah, they're starting to, as Lloyd Pye, everything you know is wrong is a video I recommend everybody watch.
Yep.
It goes into the genetics in 200,000 years, 250,000 years only. We have 2,000 to 3,000 genetic disorders that will not kill us, but we have 20 to 30 that will kill us before we can put our genetic code back into the pool. How did they get there? Monkeys and gorillas, they only have 20 to 30 genetic disorders, and they've been around for millions of years longer than we have. That's not possible how that works. They should have more than we do. How is that possible? Well, it's possible because a race of beings came down, genetically modified the species that was here, took a hominid off of the planet, probably a smaller one from the Indonesian area, and genetically modified its DNA, maybe took it to another star, planet on another star, messed around with the DNA, created humanity.
You see, the only thing is that I love this hypothesis, mind you. I know I'm aware of it, but we do need to keep an open mind also in another direction, meaning we don't necessarily have to put ETs in here. It could have been our ancestor that did this stuff. It could have been
they could have been technically advanced.
Biological
could have been energy flows from the Birkeland currents at different frequencies, changing our genetic makeups and.
Actually, that has not escaped me. That has not escaped me either. Like we talked about before, the properties of materials could have been different under different electrical environments. Just like if you heat up, if you change the temperature, the physical properties are different. If you change the charge, perhaps they're different as well. Now, there's some scant evidence for this, but there is some historical, or at least some evidence to define some of these things. Like, for example, as Lloyd Pye pointed out in his video, Everything You Know Is Wrong, it appears things like the cheetah were engineered or at least bred, and they seem to have, because they're all basic clones of each other. How the heck did that happen? That's very interesting stuff. I find that very fascinating.
Can I mention something that is really perplexing to me?
Sure.
That there are studies of dinosaurs going on, that they're melting their bones and they're finding blood vessels, blood cells, soft tissues. If they're 65 million years old, I'm going to eat my hat. There's no way that
I don't think any of us think that anymore. At least not.
Yeah,
the
there's
EU
no way
throws such a big monkey wrench in that whole thing.
Yeah, 13,000 years ago was the extinction event for most of the big dinosaurs, and some of them stayed around for a little while until the second event, when the younger Dryas warmed up and the Ice Age ended. When the second devastation happened, that wiped them out totally. Most of them got incorporated into the plasma flows from Mars to Earth, and they got encased in rock, and they turned into fossils, like Mud Fossil University. At first, I thought he was crazy.
We talked about that.
At first, I thought he was crazy, but now I'm starting to reconsider my thought on that.
I mentioned that a couple weeks ago. We were talking. I said, this guy is claiming that, like, the heel stone of Stonehenge is actually a foot, and these are actually organs that have turned to rock. And he's showing us things that look like organs. And
you can see the internal structure of broken statues in Egypt and stuff. Yeah.
But now you're right. I have to question a lot of these things. But we've seen this before. There could be a field of dinosaurs. But we also seen. Me and Robert were out with that Wesley fella there, Robert, and he was just walking along, and he goes, oh, and he goes like this, reaches down the ground, and goes, there's a dinosaur bone. I'm like, how do you know? And he goes, yeah, you find them all over this. I go, how big? About this big. It's, not even the size of a baseball. And, oh yeah, this whole area is covered with them. And he goes, well, this is not laid down by water and that this thing were like ripped apart by animals. This thing was blasted to pieces, and to think about that this is, there's a possibility then that, whole organs could be, preserved, so to speak. That is not escaping me.
Consider the processes that have just been released by the Thunderbolts project carving out the southwest of America. Do you think that would not rip a dinosaur apart?
Yeah, because there would be things living there at the time when that stuff was there.
And as I understand it, some of the concentrated devastation was happening on the North American continent, but only on portions of the North American continent. It wasn't like totally continent wide. The rushing winds, the fast winds feeding all of the southwest carving and the melting of the northern polar cap may have contributed to a lot of the things that we see, right?
I love this video. I mean, this video, you guys going into the shop.
Oh yeah, that's the Oettinger's Rock Shop in Moab, Utah. If anybody ever goes there, it's like right as you're entering the city from the north end. Right there, it's a huge rock shop. They got that green one there is the Malachite Man. That's like a thigh bone, completely petrified next to that lamp there in the case.
Made of malachite. And I love that. This is where Edwin goes and says something like, "Well, if you take these things out of here and change and combine those two atoms together, boom, you're silicon or something."
Well, I was just going to say, or was it changed to malachite from bone?
Yeah. And this is very much speculation, but if you look at the ratios, in living tissue, and you look at the calcium and the oxygen content, and you have that ratio of those two elements, and you look then at silicon oxide, and you take the assumption that you put oxygen and a carbon together, creating a silicon, then you just about get silicon oxide from that mixture from biological
tissue. There's Tesla in the corner. I didn't notice.
And I mentioned this to Neil yesterday about Mr. Japp's talk about snake going to 150 miles away, creating 2 diamond mines.
In Australia, that's where they found the second diamond mine by listening to the Aborigines, and they asked them, okay, where did it touch down? They said, over here. They went and found another diamond mine. I like that. I like that story. It's sort of like a proof that these tales were not bullcrap,
I can totally see a kimberlite pipe. As a volcano, extinct very old volcano, as they are presented, I don't believe that at all. I really think it's some kind of
electrical discharge,
moving
90
a real
degrees
strange
to the surface of the planet.
And that thing cooks the material and transmutates part of it, and that's why you find a different chemical composition. Of course, while this whole column is being cooked due to the electrical discharge, you would get light gaseous elements bubbling and gassing off, like a soup that's boiling. So it kind of sort of resembles a pipe a little bit, right? Like a magma pipe. And it would explain why the crater falls in a little bit, because it does lose material in the cooking process, right? So it falls in, so you have a missing crater.
Material being water, all rock.
Yeah. So
everywhere has a certain percentage of water contained within it, and if it heats up, it's going to escape.
And the strange part is these cones, they have an indentation instead of a lava cone. So where is that? And then they say, it exploded outward, and then you have this solid pipe. It doesn't dry.
Look at the ancient pictures of Tunguska when they went and they excavated Tunguska. Look at the depression in the earth. That's from an electrical discharge that left that point and went up to the comet and exploded it.
about 7 miles, they say. But that's
actually, it was 5 miles.
5 miles, and maybe I was thinking kilometers. Then that was an estimate on how high it was up, how high the airburst, the 20 megaton airburst was. That's also pretty impressive. What impressed me most?
Right, and Wallace Thornhill, mentions the copper plug that hit the comet. Boom, boom, 2 flashes, not just one. I'm thinking that exact thing happened, and the evidence of it was that little depressed crater left.
It's actually
in that area.
It's actually even more interesting than just that, because when you're talking about like the magnetosphere, you have to understand that the comet itself is a charged body, and it will create currents by moving through the plasmasphere of the Earth. So one of the things that was interesting is that for 3 nights prior to the morning that Tunguska occurred in Siberia, the whole sky was filled with this aurora, because it's coming in and it's charged body, and it's basically moving charge. Thus, it will generate
it's negatively charged,
electric field and so forth.
And it's pulling electrons out of our atmosphere
towards
making our atmosphere become excited.
Clearly, now electrically speaking, we could debate semantics on exactly what was happening, but suffice to say, in no predictions of any sort of model should there be events prior to the event in a kinetic universe, and in this case, it almost belies an electrical connection.
Bingo.
I think, anyway. It's very convincing.
That's why I said bingo.
Well, I always just like to add, like, I want to recognize that I'm not always 100%. I might not be 100% right on anything, and it's a safe bet to say that chances are you're wrong. But on general principle, only because if you were right all the time.
Can we get a bingo from everybody else? No?
I don't know.
I just wanted to say that I've posted a link to the chat window. It's a paper about exactly the influence of Jupiter on Earth. Turns out that when we are connected to Jupiter through the lines of the magnetic field of the solar wind, then the cosmic rays that are trapped in Jupiter's magnetosphere can escape and basically go all the way to Earth, like pretty quickly. So, and actually this is a general rule, even when we observe these energetic events on the sun, that like solar flares and coronal mass ejections, as I've said, there are not only this regular plasma, which is pretty slow, like the solar wind itself, the protons and electrons. But during these energetic events, there are also certain much faster particles. Well, they are also protons and electrons mostly, but the difference between them and regular plasma is their speed. They're like traveling super fast, like 30% of the speed of light or something like that. And so when the flare occurs at the place on the surface of the sun, which is connected right now to us with the lines of the magnetic field of the solar wind, then these fast particles can basically ride this line like a highway, basically, and arrive at Earth very quickly, like in maybe half an hour or something like that. Whereas the regular solar wind takes at least 2 days to reach Earth. So this is basically the same process, but with regards to Jupiter. So the particles from Jupiter supposedly also travel these lines. And notice how curved it is. Mm-hmm. It's not even a conjunction. It's really far away from a conjunction.
Yeah,
but it's how.
Great.
Are these lines part of our cometary tail? Because I'm thinking that all the planetary bodies and everything produces these cometary tails to a lesser or greater degree depending on the size of their magnetosphere?
Well, the curvature of these lines comes from the fact that the sun is rotating. If it was purely stationary, if it wouldn't spin at all, the solar wind would just come radially in all directions. But since it's rotating, again, this is the very same Parker spiral that I was talking about earlier. This is this curvature. And what's interesting about it is that it's so curved, in fact, that for Earth, for example, the solar wind comes not head on from the sun, but like 45 degrees to the side which we're orbit. So we're kind of catching it
to the bow.
Well, if we look,
what I'm looking at what I think is happening with the solar wind is it's confined to a certain band between the positive and negative fields of the torus that are generated by the Birkeland current pushing through the sun, and though that solar wind is confined to that band until it gets to the outer edge of the torus or heliosphere or heliopause, and get shoved up back or back down, back into the sun being pulled in along with the Birkeland current energies as well.
And where do you think this torus is located? At what distance?
The torus is the heliopause.
Oh, I see.
Oh, I see what you're saying.
Yeah, it's massive. I mean, it's our heliopause when Saturn's heliosphere / heliopause / torus touched our suns. Everything happened, right?
You mean there was some sort of reaction?
Well, Saturn went mini-nova once, and then when Jupiter came close to it, it went mini-nova again. And with the energies that
is Talbot's
between those
idea,
two large worlds, right?
Is it Talbot's idea that is this one? I'm not sure which one we're on.
No, it's just stuff that I've seen on the videos and trying to put two and two together in my own head, right?
Right. Okay.
Plus, there are descriptions of on the Thunderbolts videos where they say the sun's heliosphere touched our Saturn's heliosphere and it went mini-nova, and Venus was born from Saturn, as the Greeks witnessed.
You know that I have. I definitely know about the witnessing about the event, but I didn't know. I don't know exactly where it occurred. Was it something that was when it was already deep inside the heliopause, deep closer to the sun, or did it occur when they just touched? This
I
is
would think
interesting.
It happened when they just touched, right?
What's touching? I mean, that it gets into this whole. It ends up being the same type of thing that we run into, where there's an action that's like a capacitor or discharging, etc.
Oh, definitely.
That's I mean, can usually be predicted, that whatever that point is, but these. What is that point of like combustion, basically? So because they're touching all the time, really.
Right.
Well, in some way.
Does a nova have to be an instability of too much energy going in, or could it be also a lot of energy shutting off in a quick amount of time, and then it finding itself in an area of space that is differently charged than itself, and then poof, a nova? Could be maybe both circumstances, right?
Well, there is. As Jacob Gable, we were talking with Jacob Gable, there is such a thing as an inductive kick. Once you shut something off, you're going to get the magnetic field itself is an energy storage device, much like a capacitor is an energy storage device. And that if you suddenly have current going somewhere else and not across the inductor immediately reverses voltage and begins to expel that energy that it has built up. If that happened in a plasmasphere situation, I can envision something happening that would be pretty nasty. I don't,
right.
I don't exactly know what it would look like when I think about it now, but.
Right. Would it be the fact that when the two heliospheres touch, the Birkeland current that was feeding Saturn was taken over by the sun because it was more powerful?
Well, we've seen Jim.
Possibly.
Jim is the gentleman who's very accurately showed the local the cloud. We call it the local cloud that we're in, and we seem to be on the edge of a tube. So we're trying to get a vision of what this current might be. Are we connected to the tube and there is a direction to the heliopause, or is a current going straight up and through the sun? You see, so you see this cloud that's a pretty good example. But there's
I would imagine there's a galactic wind, not only a solar wind that our sun produces, but a wind that our galaxy produces that we're pushing through, that our heliosphere is pushing through as well, right?
Well, what we're trying to learn is, especially with years of observation, is trying to picture how we seem to be rotating around the edge of this tube. Or am I lying, Jim? I don't know. I don't want to misrepresent you. I'm sorry.
Oh, we're in one of the circles of the counter-rotating drums in the Birkeland current that's coming off.
That could be it. That's what we're inferring.
Yeah.
That we're trying to understand. Yeah.
Well, as I understand it, we every 25,000 years, the Earth and the Sun dip down into the other region of the charge. We go from a positive charge to the negative charge space. Every 25,000 years, we pop back out to the other side.
I honestly have
Jim,
no idea.
You want to interject? I heard you doubling up there.
Oh well, yeah. That's the part that's easy to map out is the larger scale filaments, not the one that goes like through our solar system, but the along the spiral arms of the galaxies down to the local chimney. That's a smaller scale filament, and then our interstellar cloud, which fits in there. Those are the easy ones to map out, just because things are visible on that scale that aren't on the smaller scale. But from that, you can see, you get a lot of the dynamics down. You can understand what's working.
This is one of the things that, what we looked at. Jim introduced me to this, and I had a chance to make an attempt, at least, at illustrating it. But this whole idea, I think, is it Richard that joined us today? That he mentioned, where it's all
Yes.
the way up and all the way down, the same pattern. This is kind of the one of the big indicators of that, this filamentary model that Jim is presenting.
Yeah, the basic idea, the easiest thing to start with is know that if you don't like the idea of frozen in magnetic field lines,
which we hate.
Right. Then what you have is, if you have a large scale current filament and that has a Bessel function magnetic structure, then that magnetic field becomes the background magnetic field for smaller scale filaments, and so on and so on. And you can trace these all the way down from the idea of current flowing along the spiral arms. That does have, and you can match this to the mainstream astronomy observations. That should have a Bessel function magnetic field along the arms, and then you should have, like our local chimney, which is one of the helical streams around the spiral arms. We're inside that, and then our local interstellar cloud is even smaller scale filaments that fit in that, and so on. And then that 24,000 or 26,000 year our precessional cycle is just the spiraling of those clouds. And the best visual of that still is the double helix nebula. If you look at the double helix nebula, you see that even according to mainstream astronomers, they get a 10,000 year spiraling. That's the same order of magnitude as our precessional cycle. That's the key to just assume that our solar system is moving like that, except that instead of 10,000 years, it takes 26,000 years. And the orientation of our solar system is always aligned by that spiraling. Mm-hmm. That's the real cause of the whole precessional thing. That's where you have to look at all these independent researchers, the little tricks, the little tips, like Walter Cruttenden's idea of
the little anomalies.
Yeah, like he argued that our whole solar system, and not just Earth, is precessing in 26,000 years, and that's important because that had better be right. Because if our solar system is strung on a current filament, and current filament spiral, then our whole solar system better precess, and that's what he found. And no one wants to listen to that, but I mean, in the mainstream, obviously. But
don't we see some of this precession?
As I understand it, the Mayans based their calendar on this cycle.
Right. Well, that cycle's really important, and it passed down.
And it may even explain our precessional wobble, our 26,250 year
likely
wobble.
Does. Likely.
Right, it does.
Yeah. It's built into the fabric of our civilization. Ultimately.
But again, that wobble may be new to us because of the change when we were influenced by Saturn. We were held in Saturn's grip, not having a wobble. I suspect that our precessional wobble is a new phenomenon known to humanity.
That's the debate. That's the debate, really.
That's where you really have to read Hamlet's Mill. That was that's incredible.
I highly recommend it.
Just how ancient, how far back they can trace the precessional cycle, and how many repeats it, and how they know how it differed from one cycle to the next. Like how in other words, longer term tracking. They didn't just say that the pole circled, but it circled and drifted off over time. Which,
we also see that with comets, don't we? Someone pointed that out, that comets also seem to follow the right-hand rule and precess as like a flower as they go around. Am I saying that wrong? Did you say that, Jim, before? I'm not sure. I'm sorry for interrupting.
No, I didn't really. That's why I was interested in more of what Eugene had to say on like all his cometary orbits. He left his presentation with a lot of questions. Like one of them that's fascinating is how cometary orbits relate to other stars. Or to me, it was like that filament that we're on, that the gas cloud that the mainstream has mapped out. That's what's.
Pardon me. So you're saying that that the scientists today can see this precessional wobble happening on the planet for thousands of years? Like 20, 30, 40, 50, 60,000 years?
It seems that it might be affecting the whole solar system, not just our planet. That's the cool part.
Right. And that's what the data from it got handed down mostly in the East, because that's the basis of their Yuga cycle is that precessional
Then it
cycle.
affected Saturn as it being a star, and us inside Saturn as well in this cycle. Yeah, that makes sense. Sorry to interrupt.
So I have a question. Wouldn't there be more visible evidence of helicity and large-scale cosmological observation than just this one instance, if it was so prominent?
Like, you mean like the double helix nebula?
Yeah, it depends on how much energy is coursing through it, whether it's in dark mode, glow mode, or high energy mode, right? If I'm not correct, please.
Right. But wouldn't we see? Right, but wouldn't we see more? I mean, is it just because this one happens to be in glow mode that we see it?
If you look at our local interstellar cloud, you can see in it an axis that the cloud is actually spiraling.
Right. Correct me if I'm wrong, but in radio telescopic images, they see the magnetic fields flowing around each other, even when we can't see it with our naked eye. But they see it through the telescopic images.
They can't see the right that that was my starting point with the.
This is actually you just poked a bear with that one. I remember this topic. He's going to go on this one, so go, Jim.
when we look at the double helix nebula, what the mainstream says is there is a magnetic field along the axis of the nebula, but there's no magnetic field wrapped around it by the right-hand rule, and that's a puzzle. Now, that makes sense if that double helix nebula is a field-aligned current, then yes, it should flow along the background magnetic field, and that's what they see. But then where's that magnetic field wrapped around it? And that's why when Donald Scott came out with that paper that said the magnetic field keeps reversing directions, that's the answer. That's why you don't see it. In Faraday rotation, what you need to see a magnetic field is a continuous, basically, if it keeps flip-flopping, that's going to cancel in the Faraday rotation measurements, and you don't see it. So all they see is the background magnetic field along the axis of the double helix nebula. That's the magnetic field for that field-aligned current. But the magnetic field of that whole structure, that's the reason they don't see it. See, like if what you would expect if the field
it's called harmonic resonance.
What's that?
I would think that's akin to sound and harmonic resonance. No.
Mm-hmm.
Well, we'll get into
I
that
don't think so
as well. You may be looking at a situation where it's highly coherent. I think maybe for Buddy's question, this is from my perspective, and once again, please correct me if you think I'm on the wrong direction. But I think there's a coherent instance that we're seeing here of something that is occurring, perhaps in a more that we can't see as often because it's incoherent.
Yeah, we don't want to base all of our suppositions off of one instance,
right?
Of the double helix nebula,
Absolutely.
and I mean, I'm 100%
It actually is an
helicity.
exception.
And I mean, it's vorticity, helicity, and torality. It comes down to fundamentally. I'm a big proponent of all of this. I mean, I like it. I love it. And I want to believe in it. I thoroughly want to wrap my mind around it, even into my qualia, inside of your brain. I want to take it to that level, to where we can.
I'm not cutting your head open, no matter how much you asked.
A qualia? Well, is that like is there a ganglia of qualia?
Well, my point was it's not the same process that happens with sound cancellation, but it's visual cancellation because of the back and forth interaction. It just cancels visually for us as the same effect of noise cancellation.
I see what you're saying. Yes, Jim, that's exactly what Jim was pointing out. The field, because they are wrapping around themselves and they are at a minimum energy configuration in many cases. Obviously, we can see there is a big curve. There's a big voltage, the voltage and current curve. Basically how much something filaments and where you are on the curve. Like Geiger counters work here. Townsend discharges are here, lightning bolts are here, type of thing, on that chart. It's as Donald Scott said, laughably unlinear. If we see some filaments in a particular mode, just by changing the voltage amperage characteristics, we can push that into a different area. And this could be something that we're seeing. It's going in. It looks slightly different than what we're inside of. But also, we're trying to image it from inside too, not from the outside like this one. But sorry, Neil.
But wouldn't ramping up the power flow, the amount of flow of energy into that system, cause it to glow or not to glow? Right.
Well, we also don't know what we're looking at here. We could be looking at something in dark mode, and we're barely seeing this nebula. I don't know the imaging structure of what we're looking at, so I can't even judge. However, I do know that it's different than, say, the Red Square Nebula, or that beautiful one with the lobes coming out that look like just one pinch, or it doesn't look like the Crab Pulsar. It also doesn't look like the images exactly of the center of the universe or the galaxy, Milky Way, which we just recently saw. All of them are different, but they all have, number one, they're all imaged by different machines, but they all have different characteristics because each one of them is on a VR curve, or different on the VI curve of the voltage thing. But anyway, that's not really important. The actual thing that Jim was saying was with regards to, because they are layered, these field-aligned currents or Birkeland currents are layered, although they still respect the Coulomb or the Ampere's law, which is basically if a current goes one way, the right-hand rule says that the magnetic field wraps around in this way. It's not necessary because it's also because it's causing a wraparound in the opposite direction of the layer below it, and in the opposite direction with the layer below that, and so on and so on. So it cancels itself out, if I'm not mistaken.
Are they shielding? Is it like they're acting as a shield, so the outer wrapping acts like a shield to our observation for the inner layers?
Well, we do know it has to obey that law. It has to obey Ampere's law, so it can individually wrap and break itself into currents or rings.
Well, everything, as I understand it, Tesla says everything is frequency and vibration and energy. And if we're talking about things that manifest themselves down at the quantum level so that we can visually see them, then it's almost it's almost intuitive that it's doing that at the quantum level so that we can't see it. But when you ramp up the energy, that changes the rule.
It's the scale too. The relation of scale, time, and frequency related to scale. You're seeing these multiple scalar frequencies here. I mean, this one has been really striking. The shot of the galactic center.
Oh God, yes.
You see these vorticities and everything. It's just amazing. But this one certainly has a window into quite a number of ideas, I think.
Right, and if there is a plasmoid in the center of our galaxy, like
seems to be
the
several
universe says, then you could see all of these energized things bouncing around, little tornado things. Yeah, that's wild.
All right.
And also, we should also point out that there are technically two currents here. So the plasmoid in the center, we're seeing this part over here to the left seems to be closer to us, and to the right seems to be farther away. We are looking at it on an angle going across the galactic center. We're getting an idea of that the center is the interaction point between these two currents. One to the left that seems to have a string going down at there or the right that has that long string, and over here on the other side it's even closer and bigger because it's that much closer to us. Or so it seems.
Isn't the plasmoid at the center of the galaxy not a black hole, but a really, really highly energetic space or portion of space / battery that holds massive amounts of power and energies that would basically rip you apart probably. If you tried to enter into it?
Yeah, I mean, it's this plasmoid.
But the arms...
Focals.
Because of the Faraday disk, the homopolar motor mechanism that likely is how the galaxy functions, if we're doing it just being fair, you're going to have a multiplication of current at the center because of this. There's a magnet inside 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 a magnet, so on down, and because the law of it's basically like twisting a bunch of wires in a transformer. You're multiplying the action, and this is usually called a dense plasma focus. Basically, is what the name of it, and it is one of the things that even on Earth they recognize the potential for it to possibly have caused nuclear fusion. It's quite powerful. So.
Right. Yeah, and a lot of people out there are searching for 0-point energy. Well, I maintain that that 0-point energy is the plasmoid of any object that has Birkeland current connected to it at the very central point where the two fields are together of the plasmoid. That's where you can draw energy from, because it's a little plasmoid, a little battery that you can pull energy from. And a lot of people mistake free energy and 0-point energy as some magical thing, but it's not. It's just the flow of charged particles that are connected to anything that's separate from any other piece of matter, like us on the planet.
I liked the idea of free energy, but when I realized, and 0-point energy, of course, I mean, big fan of Fringe, great show. But one of the things about the whole kit and caboodle of the that is that it's not necessary anymore. We do not live in an energy disparate universe where we are a ball of rock separated from, and there's a nuclear fusion going on. So we're all connected. There's a lot more energy out there. If we wanted to, we could easily blow up an entire continent, probably, if we just decide to short out across the ionosphere and all the charge rush to meet that point. It would be devastating. Like, I
think you misunderstood my point. My point was being that people that are looking for free energy and the 0-point are mistaking that for the plasmoid effect of the Birkeland currents passing through our Earth, the Sun, all of that. The 0-point is basically the Birkeland current making that plasmoid, creating that plasmoid on a piece of matter that it's running through. That's the confusion that most people looking for 0-point energy find. That, okay, well then there's a vast amount of energy being stored, and how do I tap into it? Well, it's not that energy, that battery that you can tap into. That's just the result of the Birkeland current flowing through that piece of matter, creating that energy. And the people that are searching for free energy and 0-point aren't realizing it, but they're tapping the flow off of the Birkeland current, basically.
I've actually, like I said, I've never really seen any of these. The closest I've seen was one gentleman, but I remain. I mean, I've seen. Obviously, there are people who are doing, charge phones through the air, and now this gentleman can pick up, has enough ability to use the power coming from a couple antennas, using a couple op amps, and can make a cell phone work and connect to a tower even without a battery. So
well,
that's interesting
the
stuff.
reason why telephone companies made it illegal for you to string wires from telephone pole to telephone pole and draw the power off of the ambient power that's in the air from that system is because they don't want you to have free energy. And using their poles, their transmission poles. It's not that you're pulling energy from their system, you're pulling energy from all of the electrons that are slamming into that wire and then running along the wire to the positive and negative poles that you create.
Oh, are you referring to people?
And it works on railroad tracks as well.
Yeah, we were talking about that, about the idea that you can. This is where things like the Carrington event and other things become very interesting, because with all the wires that we have, and each one of them represents, in many cases, each one can represent a loop. And as anyone who studies electrical engineering knows, is if you have a magnetic field crossing a loop, you're going to have a current flow in the wire, and this is where. Would society even survive something like that? How much would survive these type of events?
Well, as I understand it, the Carrington event really only caused damage in certain portions of the United States. So I'm guessing from that knowledge that it's working exactly like how craters are created, coming down in a big energized loop and then concentrating down
it should be in
to
loops,
a certain point, and then coming 90 degrees to the Earth in a certain area.
That's actually fairly. I mean, generally speaking, there should be an induced current, and that induced current is what's causing the problem. Which means that there are magnetic fields moving quickly, or at least changing magnitude in and around that to cause that induction. I think that would be fairly accurate to say in that particular case. Of course, this was 1860 something, so or 50 something. I don't even know. But,
sorry, I'd like to say that these charged particles are the energies that create your magnetic fields coming from space, penetrating in through our magnetosphere and touching the Earth and running along these wires, gathering along these wires and creating a current, right? Along the magnetic lines that you're talking about.
They do it whether or not there's wires or not, actually. That's where telluric currents come from, for example. And we suspect now, especially we've gone into the EU really has a future in I think in meteorology because it's probably the missing thing that would help make long range forecasting even better. I think it has the potential there because of the inclusion of magnetic fields into electromagnetic forces into weather. I mean, it would explain things like, the jet stream alone, stuff like that. So
right, yeah. Well, as if you can change all the meteorologists' minds into thinking,
they'd be easier to change
in terms of pressure is not pressure, but it's an electrical difference or voltage difference in areas of the sky. Then yeah, you would be able to put it all together for them.
You have to sort of reverse their cause and effect mantra, which is the wind itself and hail rubbing against other types of hail will generate charge, and that's what makes lightning, which is patently preposterous. So there's
well, I would imagine there is some truth to that particles rubbing against each other like rain particles or
Robert could tell you
dust.
There is no lies.
Yeah.
Is it true you worked on an aircraft carrier, didn't you, Robert, and you saw what happens when you don't properly ground out a plane or a canopy or something?
No. I didn't actually see it. It was just in the training manuals because I was a firefighter.
Training, good, that's good.
They come down, those canopies can be loaded with almost 100,000 volts, and even as Jim said, if you're trying to refuel a plane, you better make sure that thing's grounded or you're going to blow yourself completely in the next Tuesday. And they do that every time. Every time they had to park the plane after trafficking it, and they would secure it down and then ground it so they could refuel it. And if you had to do a rescue, you had to actually ground the canopy before you just broke into that thing, because if you hit it with a crowbar to smack it, you'd zap yourself.
Yeah, that's... these are things.
What do they use as a ground? Do they have like?
They have what's called a static glove. They have like a wand that is hooked up to a ground wire, and then it has like some kind of protective secured material. It has like a foil net woven into it, and it just as you like with a little glove on it, with a literal hand, and you wave it over the canopy, and it just sends the ground down to where you like secure it to a pad eye, which is where you usually chain the jets down by either wings or fixtures that are inside the structure, like on the struts and the pylons and whatnot. Not necessarily the pylon. There'd be fixtures in the wing to chain them down, and then whatever it's called. It's like a star pattern welded into the deck. It's called a pad eye. So that's you would hook that to the ground wire, and then you just wave it over. Once it's grounded out, after like 3 passes or something, then you can either bust the canopy open or wind it up.
And this is open to the ocean or something?
Yeah, this is like during flight ops on a carrier. Yeah, it's what I was trained on. They also have different procedures, I'm sure, for air bases on the land, but they're still similar for refueling purposes, because they do develop a charge up in the atmosphere while they're flying.
Okay.
Yeah, and the universe isn't electric, and your charged canopies are just, not real.
Well, admittedly, though, there is a possibility, and this is not it's not a lie. I mean, there's basically a lot of wind going across. We know that if you rub glass with fur, you'll build up a positive charge. That's so.
Or silk.
Well, silk, yeah. But we learned this. This is like where we got to where we are today. So there is certain things that happen. Is Scotch tape is a perfect example. There's a particular brand of Scotch tape that where you pull it apart, if you were to do it in the dark, you would see a glow right where it's pulling apart, and that glow is occurring because of that particular effect. It's quite interesting that so there are materials that will do that whenever you rub them. So I could picture it being friction, but to take that and then to extrapolate it to ice crystals without any experimental evidence that this could even happen, I don't necessarily buy that.
Neil, I'd like to draw your attention to easy water. Easy water doesn't need you
don't need to draw
apply an electrical charge to it, right?
Dr.
It
Daryl
does
Hog's
it all automatically on its own.
But yeah, easy water is in a way it's sort of like it's almost similar in characteristics to a chemical double layer, because there's chemical double layers in chemistry as well as in electrical plasmas. But something very interesting happens in that particular thing, and I love the concept and how the likes principle, as Feynman would say, leads to clouds and so forth. That was a big topic not too long ago. We had Phil Francis on. He did a whole presentation on in that regard, in that vein. So
very cool.
Right? Yeah.
So what do you think? Should we call it a show?
Oh, it was definitely a show.
With the astronaut getting attacked by the birds.
Because that happens.
Can I have
that happens.
Go ahead, Jim.
Well,
yes,
one more
absolutely.
comment. I don't know if I ever shared it with you guys. I mean, even from the beginning on that, on our local interstellar cloud, one of the ways that you know that it's a Bessel function filament is that the magnetic field. If you're in a Bessel function filament and you look radially outward, you'll see a magnetic field direction that there's no line of sight component of the magnetic field. On all other directions, click on one of those, the local interstellar cloud images for a second, the one that shows star. Yeah, that one. Interestingly, if you look radially across a filament, you won't see any line of sight magnetic field towards you, correct? If you look on any other sight line, you'll see a magnetic field that changes direction, either has a component towards or away from you.
Okay.
But if you look axially down the filament, it doesn't matter what radius you are in the filament, if you look axially down the filament, you will always see a consistent line of sight magnetic field along that direction. And what's interesting here is when they look along this filamentary cloud towards the direction of the stars out ahead of us, see that OPH, for example, stars in that region.
Mm-hmm. What
the mainstream found is a consistent magnetic field orientation along that sight line, and that's really key to knowing that we're in a Bessel function filament that spirals along the same axis that you would draw in there. See what we should, when we look at other stars, what they see is magnetic field directions that flip, and they think that there's magnetic turbulence doing that, but along the sight line of this filament, they know that there's a consistent magnetic field direction in the Faraday rotation measurement. So that's exactly what you would predict in a Bessel function filament. So that's how you know that's right.
I like that you can actually take. This is what I mean by if you ignore the laws of EM, you're going to have a bad day. They don't end at Earth. it's quite clear that you can apply these to plasmas, and obviously should. Not to just say that Newton needs to be dismissed or anything. He just needs they need to be incorporated and given the same weight.
Yeah.
So the equatorial field of the sun, if you will, the planar field, so where the planets orbit in, is that exactly perpendicular to that orange line, if you will, or?
That's a good question.
No, actually, you can. It would be nice to. I've been always meaning to put all these different features into one diagram to zoom in and out, but.
Do you know the angle, if you will?
Are you asking what is direction of sun's motion is relative to the planes of orbits?
I think so. Yeah. Right.
It's like 62 degrees or something like that. So basically, if you're looking at this picture, then the horizontal line would be actually the plane of orbits of most of the planets.
Mm-hmm. One of these blue, like these.
Well, no. I mean the horizontal line. If you kind of
this line.
Yeah.
Uh-huh.
Yeah.
All right. Okay.
So there would be almost 60 degrees between it and the directional motion.
Right. See, another way is to know that, like, whereas Sirius, like 40 degrees below the ecliptic or something like that. So that gives you an idea. But the point is, the reference frames there for the sun's direction of motion doesn't matter at all. That's how we're moving using the galactic reference frame, but you're ignoring then that those clouds are moving also in the galactic frame, and what you really want to do is pin the sun's motion to the cloud, and that's what's important. It doesn't matter if we're both, and that's the right way to orient the solar system.
Yeah, sorry, I might have misinformed you in this. I just thought about it. Yeah, you might be correct in the regard that I was talking about the direction of motion around the center of the galaxy, but it doesn't mean that with respect to these objects we move to this.
Okay.
So maybe this yellow line actually shows the direction of motion with respect to these stars. Because these stars also orbit the center of the galaxy at the same direction as the sun, because they are really close to us. But maybe this picture only shows the relative motion of the stars. So then the plane of the planets would not be horizontal here. Then I don't know where it would be.
Yeah, see what it is important to keep the mainstream picture in what they're trying to map is what they think is happening is the sun is going to keep traveling along the direction in that arrow, and that those clouds are going to just blow past us. In other words, the sun has nothing to do with those clouds. That's just clouds that are blowing across our path right now. And it just happens, though, from the mainstream literature, what you can get is that we are skimming along the surface of the cloud where they know all these electrons are from the radio simulation screens. So if the mainstream is right and we are on a large-scale elliptical orbit around the galactic center, then yes, we're going to leave those clouds. But if we are, in fact, spiraling, then we're going to stay with the clouds and curve along with the clouds. And that matches all this precessional data that the ancients passed, where they said the pole was at times in the past, matches that. See what?
And then what's the role? What's the role of this guy too?
That's what the Sirius Research Institute was about. Is he found that star kept in sync with our precessional cycle, which is going to happen if a star is spiraling along with us. Then even if our solar system precesses about an axis, and another star is going to be spiraling around that same axis, you'll get that sync up of that's why that happens. That's just evidence that Sirius is in that same it's in the same filament and traveling along,
in the same
spiraling around
direction.
at the same. It has to be spiraling at the same rate if it's keeping up with our precession, and that's what a lot of people miss with that instantaneous idea that Sirius could right now be keeping up with precession. That makes sense. If Sirius was traveling in a straight line anywhere, it could just do that at one instant in time. But these guys pointed out that the Egyptians said it was doing the same thing. Well, how can
not only the Egyptians, but the Dogon tribe hold Sirius in high regard.
Absolutely.
They knew thousands and thousands of years ago that system had 3 stars and a planet orbiting one of the stars that is very important to them.